Yeah, everyone, hi. Today our topic is EIGRP, Enhanced Interior Gateway Routing Protocol. So it is a IGP protocol. It doesn't mean Interior Gateway Protocol. It means will use as a within AS, within autonomous system number, within an organization or inside a organization, you can assume. In if we have connected two branches, so here we have a LAN network. So this LAN network is connected to multiple departments, and this LAN network is connected to multiple VLANs or multiple departments or multiple floors, multiple access layer switches. So these all the access layer switches having unique prefixes, unique VLANs, or they have individual VLANs for each department, like individual VLAN. So those having prefixes, we call it as a individual IPs or individual 192.168 some 10.0, this 10 dot network and 20 dot network and 30 dot network. Let's assume we have a up to hundreds of network, hundreds of prefixes. These all are the LAN prefixes. So this multiple LAN prefixes will advertised through any routing protocol. So any routing protocol, through it will be reached at different location. Then only the branch one can communicate to branch two. Then only they communicate to each other. It's a LAN network of different location. Hyderabad location, you can assume it's a LAN location of any Delhi location, any Gurgaon location, any different location, any worldwide. It's a US location. You can assume this is a India location. So we have a multiple prefixes, multiple departments. So we'll advertise at one routing protocol. Then only it is possible to reach at one location. So what we call it is, it's IGP, Interior Gateway Protocol. We call it as a IGP. It's IGP here also. With if want to communicate IGP to IGP, it's LAN to LAN. We need a WAN location. We need a ISP. Those who will provide ISP, internet service providers, will provide the WAN services. Like we have like private IP, public IP addresses here, and this location public IP locations. So then only it is possible to we can communicate. So here we'll use like BGP protocol in between. It will be 2 AS. What is AS? AS nothing but to autonomous system number. Who will provide it? INA, Internet Service Number Authority. Internet Assign Number Authority. IANA, INA, Internet Assign Number Authority. Here we have public and private AS numbers. We have 2 to the power of 16 numbers we have. It means 2563 something. 253 25637 some value will become. Up to here we have in between, one is the public INA. We should have to buy from ISP, otherwise INA will provide the public AS numbers. It is kind of public IP addresses. So private IP addresses also we have, like private IP addresses we are using without cost. We don't need to pay anyone. So likewise we have a private AS numbers. Those will use in EIGRP also. You can use those AS numbers in BGP also. So likewise, we have a AS numbers. So here we have a two branches. So in this branch, same organization. It's like our XYZ organization. They are using one AS number, and same number here also will use XYZ organization only. Like Wipro, it's a Wipro company, and we have a different branch, Wipro branch in different location. So Wipro uses same AS number, like private AS number and private AS number, and in between we have a WAN. The ISP guys will use public AS number. Definitely they'll use public ISP numbers. Those they will buy from INA. If we required, they will provide to us also, but not required for small organization. If it's big organization, so if definitely we should have to buy. Understood till now? What is the requirement of IGP? What is IGP? Interior Gateway Protocol. It will be work within a network, within a AS number, sorry, within a AS number, not within a network, within a AS number, within a location, within a LAN location. If we have a multiple location, we need to communicate with the help of two AS number. Those are the EGP protocol, and IGP protocol will be used mostly in our LAN location. But now we'll discuss more about IGP protocol, that is dynamic, one of the protocol, one of the version we have in dynamic routing protocols. That is what earlier we discussed RIP. Now we are discussing about EIGRP. So now we'll discuss more about EIGRP. Actually, EIGRP, it's an advanced distance vector routing protocol. It's an advanced distance vector routing protocol. And what does it mean? It will be used like link state, and we have like link state routing protocols and distance vector routing protocols. Distance vector routing protocol plus we have the link state routing protocol. Link state. So distance vector, it is like RIP protocol. This one is RIP protocol. This one is OSPF protocol. OSPF protocol. So mostly in distance vector routing protocol, it will be work based on the hope by hope by hope. It will be have the entire routing table hope by hope. It will be generate. Now coming to the link state routing protocol, the link state routing protocol having the entire links information, this information and this information and this information. Routing, entire routing will be generated, and a distance vector, it's a legacy one, and it will be forward the traffic, like if neighborship went down or not down, it will be sent the every 30 second periodically, it will be sent entire routing table. But in link state routing protocol, it will be send the update whenever the neighborship is down, any topology changes occurred, that time only it will be sent. So it will be our EIGRP will work both. Advanced distance vector means it will be work distance vector as well as link state also. It will be work both, and both of the protocols. Understood? We need more about content for that. We call it as a hybrid also. And it's a distance vector and link state routing protocol, and compare hybrid advanced distance vector work with Belmont-Ford algorithm. It will be Dijkstra algorithm work with dual algorithm. This will work dual algorithm, and it will be sent periodic update. That is means and if any changes occur or not, topology changes occur not, it will be sent every 30 seconds. And link state means it will be send the update incremental. Any changes occur in routing table, then only it will be sent. And same thing, incremental update, EIGRP also. When it will be send a full routing table, if any changes occur or not in between two neighbors. This is R1 and R2. And R2 having the multiple routers, like they having the multiple neighbors, R3, R4, R5, like R3, R4, and this also router having the multiple neighbors. So entire routing table, it will be sent every 30 second, that is periodic update. And any changes occur, it will be sent entire routing table. But here it will be sent only missing exchange, it will be sent missing routes. If it will be sent within every 5 seconds, any missing update is there, that time only it will be sent 5 seconds. And its classful routing protocol means /8/16. It would be sent, it will be not carry the, it won't carry the subnet mask, means full up, whichever class full it is there, then only it will be send the update through class full. It will won't carry the subnet mask. But it's a classless means it will be carries 27 also subnet mask, it will be carry 28 also, and 29 also. So it's a kind of RIP protocols work here, and here we have OSPF and EIGRP will work. It's a both are the classless routing protocols. Classless means it will be carry with subnet mask. Carry with subnet mask, it won't carry subnet mask. It will be not carry the subnet mask. And less overhead, it is less overhead. We can easily deploy this, but where we'll use this protocol actually, if we have a limited branches, small organization, we don't have multiple branches, then we'll use. But it is more overhead. When we discuss OSPF ISS, that time it's more overhead, because there we should have to create the neighbor area concept, entire thing is there. But now coming to EIGRP, it's also less overhead, easy to converge, difficult to converge, and it's also easy to converge. But in real time we'll use OSPF protocol only. Here we have a EIGRP is a dual, it will be work distance also and link state also, link distance vector also and link state also. Any doubt? Any doubt in distance vector and link state? That is the reason it is a, earlier it was a Cisco proprietary protocol. EIGRP, it's a Cisco proprietary protocol. Now it is open standard also. Earlier it was a Cisco proprietary. Now EIGRP, it's open standard protocol. It means earlier only Cisco devices will use this protocol. Nowadays, every organizations can be support, means HP, Aruba, Palo Alto devices can we can use, and that also those devices also. That is the reason it's a now open standard. Earlier it was a Cisco proprietary. And it's a classless, we discussed. It's a classless routing protocol. It will be carried with subnet mask. And include all features of available IGRP. Whichever interior gateway protocol, those all the features are available because it's a hybrid protocol. It's a hybrid protocol, advanced distance vector routing protocol. Nowadays, we call it as a advanced distance vector routing protocol. It will having the entire IGP features. Even though it will be work based on the AS number, but its protocol having the entire IGRP protocol and max hope count. What does that means? EIGRP protocol will work maximum hope count, that is 16th. If 16th router hope is there, then the packets will be dropped. If we have at one location R1 and R2, in between we have a 16th hope. If R2 is a 16th hope, this is a 16th hope, 15th hope, and this one is a 16th hope, then packet won't send. Drop, it will be drop the packets. It will be drop the packet. Which protocol? RIP protocol will be drop the protocols. RIP metric is hope count. RIP metric is like hope count. Here it is not a metric, it is a hope count. It will be maximum of 255 we can use, and by default having 100 hopes. And administrative distance is 90, AD value is 90, and based on the AD value they will select the routing whichever the path, best path. If here using RIP having AD value 120, and if we are using here EIGRP, then the EIGRP are having the AD value that is 90. Then compared to RIP, having the less AD value, then EIGRP elected as a best routing path. That is based on the first one is longest prefix, then it will be moved to the AD value, then it will be moved to the metric is nothing but bandwidth, whichever the having the link bandwidth, that is the bandwidth. If longest prefix match, then will be moved to the AD value, then AD value will match both, and we are using EIGRP, it will be moved to the metric. And if metric also match, then equal cost ECMP, equal cost multipath ECMP, it will be moved to the equal cost multipath. And it is flexible network design, easy to deploy, it will be a converge, easy to convergence. That is the reason easy to deploy, also flexible network also. And it will be used multicast and unicast instead of broadcast addresses. Means it will be used like multicast IP address 224.0.0.10, where we'll use, I'll explain these things, but now time being it will be used multicast and unicast, both it will be used. Where we'll use multicast and where we'll use unicast. With the help of multicast IP address, it will be send the messages, and unicast means one-to-one direction, one-to-one communication. And it's 100% loop free classless routing. Whenever we are using the EIGRP protocol, it's 100% class loop free protocol. It won't generate the loop in between the network. Wherever we are using the EIGR OS BGP, like BGP having some loop algorithms. So no, and OSP are also having some loops. But when we are discussing here, EIGRP, it's loop-free protocol and easy configuration for WAN and LAN routers. And WAN means ISP guys also will use sometimes EIGRP protocols, and LAN and our branch ends we are using these protocols. Got it?
Sir, I have one doubt.
Yes.
Just now you informed that EIGRP that metrics include bandwidth, right? It include only bandwidth or any other like
Yes, we have
maximum.
K values. Yes, we have K values. I will discuss. It's a basic
Okay.
understanding I'm explaining. We have a K values, K1, K2, and K3, K4, K5 values. With that only it will be calculate the metric.
Okay, and does it include any components this EIGRP one?
Sorry,
Any components does it include?
means which kind type
Uh,
of components?
like uh, transport protocol.
And yes, it is a reliable protocol. It is a
Oh,
reliable protocol. Means whichever the sending the update and it will be received the update. There we have K values in K5 is a reliable only. So, and K4 is MTU, maximum transmission unit. MTU, that is the 1500, right? 1500. Whenever we are using, the packets are MTU size is 1500. MTU size is 1500. If we send a large packet, it will be encrypted like 1500 plus 1500 and 1500 likewise. It is segmented. Then once it will be reached the destination, it will be like the packet will be encapsulated. Decapsulated and encapsulated will be happen with the help of MTU. And we have a K values, the packet will be sent and receive, and it's a reliable protocol, EIGRP. I hope you got it. So, Soumya, if you have
yes,
any,
yes.
okay. Fine, guys. If you have any queries in between, ask, no issue. And it support IPX, Apple tag protocols. Earlier, we used these protocols actually. Nowadays, we are not using only, we are using like IP. Nowadays, we are using only IPv4 and IPv6. Earlier, we used like Apple tag and IPX. It's legacy protocols, but it will be support. Our OSPF RIP protocols doesn't support these technologies. Nowadays, we are not using, but it will be support. And hello packets are sent every 5 seconds, and dead timer is 15 seconds. What does that mean? Hello packets are sent every 5 seconds and dead intervals 50 seconds. Convergence rate is very fast. And the whenever we are using the EIGRP protocol in between two routers, router 1 and router 1, and here we have a router 2. In between we established a EIGRP protocol here with the help of router command router EIGRP we enable, then it will be start to send EIGRP messages. we haven't configured here till. So it will be sent every 5 seconds, up to 15 seconds, 5 packets it will be sent. Up to 5 packets it will be sent. First packet drop, second packet drop, third packet drop. Once we configured both end EIGR, it will be sent minimum 15 seconds. If it is not it is not responding, minimum 5 seconds it will be sent, and after then it will be the neighborship is not converged, then it will be drop the packets after 15 seconds. Does it mean? But every 5 seconds it will be sent, and it will be sent triggered update. Triggered, not periodic update. Triggered means whenever this router having another routers, the topology, this router also having another routers, it's there we have the entire prefixes. If this router is went down, then here topology changed, then only it will be sent the packets. And it will be not sent entire routing table. It will be sent whichever the prefixes having down, that prefix is only sent with the help of query packets. Query packets. I'll explain that thing, but now you understood. Timer 5 second. Hello packets are sent every 5 second, and dead timer is 15 second. These all are the basic concept. Once basic finish, we'll discuss more thing. And it is uses dual algorithm, and it will support equal cost and unequal cost load balancing. What does it mean? Equal cost and unequal cost load balancing. It's important thing. R1 is connected to R2 and R3 and R4. Equal cost means here we have 100 Mbps, 100 MB link, and here we have 100 MB link, 100 MB, and here we have 100 MB. So this end user sends some traffic to one more end user. So we can apply here equal cost and unequal cost. So here it will be sent we have three users here and three users here. You can assume here are three users. User one originated some traffic, then it will be moved, it will be sent through this link. User 2 originated some traffic, it will be sent through this link, and user 3 originated some traffic, then it will be used this link. It is like equal cost load balancing. Now move to the unequal cost load balancing. Here this link having only 50 Mbps link, 50, and here we have 200. So based on the packets, based on our given requirement, based on it will elected, that packet will move through faster than that. It will use likewise unequal cost also. It will support both equal and unequal cost load balancing. Any doubts in this? Yes or no? Guys, respond.
Yes.
Fine. Now move to the packets. EIGRP having the 5 packets. First one is hello packet, and second one is update, third one is query, and fourth one is reply packet, and fifth one is acknowledgement packet. See, we have two routers and they are connected. We enable the routing protocol, that is EIGRP, with the help of 10.1.1.1, and our neighbor router is 10.1.1.2/24. We enable routing protocol R1 and here R2. So first we enable here EIGRP with the help of router command. How we'll enable router EIGRP with AS number 100, we can assume. We enable the routing protocol, this is R1, and config star. We enable the EIGRP where at only R1. We haven't enabled. Then this router 1 will send the hello packets. Hi, myself R1. Hi, myself R1. Hi, myself R1. Anyone on the line, it will send 3 packets. If we haven't enabled in this router, it won't give the hello reply. If we enable, then only will give the reply. But once you enable and with network command, just you advertise the prefix like 0 and wildcard mask we'll discuss. This prefix you advertised where at R1 in R1 router. R1 again same config. Just we enable likewise with the help of network command where only R1 side. Then it will be sent 3 packets. Once we enable both the end, this router will also give the reply. Yes, myself R2. Yes, I am present here. I am on the line. It will be send the packets. Those are the hello packets. Once both are sent hello with the help of which with the help of multicast IP address. With the help of multicast IP address that is 224.0.0.10. With the help of they will exchange the hello packet with this multicast IP address. They will exchange multicast to group. If this router having one more router, like they will exchange the group of information, entire group. If this router having another router also neighbors, it will be send entire router information. Once the both send hello packets, every 5 seconds they will send the every 5 seconds it will be send the packets. If 15 seconds it is not respond, then neighborship will down. So we'll check in that lab section. But hello packets sent every 5 seconds. After then, once hello packets done, once neighborship is done, then update packets. In this update packets, hi router 2, whatever you have the routings prefixes, whatever you have the LAN prefixes, whatever you have the neighbor your router prefixes, just give me. It will be asked first hello packets, it will be sent hello both and hello will be sent exchange hello. Then once hello will done, then it will be sent give me your routing information. R1 will ask give me your routing information with the help of update packet. That time this router will give the routing information that is unicast. unicast. Whichever this router having information, that router will give the unicast. Reply time is unicast. Then this router will acknowledge it. Whatever you have given the routing updates, yes, I got it. But no, it will be give the reply. It will be give the reply. This is a reply packet. Reply packet. This is unicast. Unicast is update whichever the having routing information. Routing information. It will be give the entire routing information. It will be give who R2 will be give the routing information. Who will ask? R1 will ask in update packet. Just give me whichever you having the routing information. Give me prefixes, all the prefixes whichever you have. Then R2 will give, yes, I have this many prefixes. It will be give the reply. Then R1 will be give the acknowledgement, ACK, acknowledgement. ACK. Yes, I got it. Everything, whatever you have given, I got it. Then router 1 again asking, you have whatever prefixes, you also give me. I have shared my entire prefixes. And whatever you have, you send me. Then R1 also will send. Yes, I have the, it will be update packet only again. Update packet. In this update packet, it will be asked, router will one ask to the update packet, give me your routing table also. It will be give the reply entire the routing table, that is unicast. Then router one also give the reply, that is acknowledgement, ACK. Entire process will be happen. But here what is query packet? Query packet is any changes occur, any changes occur, he have a one prefix, that is he sent earlier 192 168 something 10.0 some prefix he sent. He have that prefix, but after 15 seconds the prefix gone. This prefix gone. Earlier you sent one prefix, now you haven't sent that update. Can you give that update anything else you have that then router will send, that is query packet actually. That is query packet. Earlier he sent this prefix 10.0, but that after 15 seconds in that topology changes occurred, that this prefix is gone down. Then earlier I have that prefix, now you are not giving any update for that prefix. Can you send the prefix? It is originated some query packet. That is the query message. Entire process will be happen likewise. Here we have a like both whenever they are sending and receiving, that is neighbor table, and whenever the topology send occur here, update, those are the updates are receiving and sending, that is topology table. In topology table, entire prefixes routing information will be happen. If you this prefix have first path, second path, third path, those many first and second path will be available in topology table. And we have a one is routing table, EIGRP routing table. In that routing table, whichever the having the best prefixes, those routing information will be have in that routing information, routing table. Guys, if you have any queries in this packet types and how the function is going on, ask me. I am ready to explain one more time also. Fine. See, first is hello packet. Both are sending hello, and update packet. Update packet, in this update, the topology table will be occur, and a query whichever the neighborship earlier sent any that prefix not available in that routing table, then it will be originate, R2 will be originate the query packet. And then reply means whichever the update packet is giving, that is reply to the R1, that is unicast, and once the both routing information both are received, that is acknowledgement, that it will be give the acknowledgement. Both routers will send and receive acknowledgement packets. These all are the packet types. And here we have the neighbor table, topology table, and routing table. Whenever the EIGRP is not available, so we can use with the help of some troubleshooting with this kind of things. We'll do likewise. We should have to check what is the issues in between with this process. This kind of troubleshooting with convergence connectivity between the routers. Both connectivity are established are now router R1 and R2, both are the established the neighbor or not. We'll check likewise in between. Whenever we configure EIGRP, we will check the connectivity in between. EIGRP is working or properly or not. Will ping test, will do the ping test also with interfaces, and IP interfaces should be same on the specific given interfaces, whichever the subnet mask we are using. If we are using both and same IP address and same subnet mask must match. If we are using 10.1 and here also 10.2, we should have to use and verify the neighborship in between. How will verify the neighborship is working or not? We should have to check the authentication. Once we use both neighborship parameters here, we have to check AS number. If we are using 100 AS here, so 100 AS here, AS should be matched. Both and AS number should be matched. Apart from that, subnet mask should be matched. Whichever we are using subnet mask, those should be matched. If subnet is mismatched, then neighborship will be not established, and AS number should be matched. And what else? Authentication should be matched. Authentication, whichever authentication we are using, if we are enabling, then only it will be matched. If you are not enabling, no issue. If you are enabling, the authentication should match both end. If you are using here Cisco, means same password here also Cisco. Authentication should be matched. Anything else? Here no idea concept. This is the thing only. Subnet, AS number, authentication. This should be matched whenever you are troubleshooting the connectivity in between the neighborship. Again, verify it. What about the K values? Here actually will have to calculate the metric with the help of K values. In this K values, we have a bandwidth, delay, load, MTU, reliability. And K1 is nothing but bandwidth, and we'll use these things only, K1 and K2. Mostly we'll use these things only, K1 and K2. But these all are the values will be changed always. So we will not use these things. Will not use much more in K. Mostly we'll use these things. Will use because load will be changed and MTU size will be also changed and reliability also change. Once packet will be dropped in between two routers, what will happen? Once the packet will be dropped, then reliability also change. Then it will be not giving the acknowledgement. So it is not acknowledged. So will not use. And MTU size, sometimes it will be some packet will be 1500, So some packets will be, it will be vary on the traffic only. So will not use. And load also. Load by default, every interface having the different loads. So it will be vary on the depending on your traffic. If traffic is more, the load will be more. If traffic is less, then the load will be less. So it will be changed. So metric also will change. If we are using the load, MTU, reliability, then metric also will change. So that is the reason these bits are off. So only 2 bits are on. So we'll use mostly bandwidth and into delay. We'll use bandwidth and delay. Mostly we'll use in metric calculation. This is a metric calculation. We'll use mostly bandwidth and delay. 56 divided by 256. Guys, any queries till? I hope everyone got it.
Yes, sir.
Any doubts?
Sir, does this K value, I mean, any range?
Yes,
Okay.
we have the ranges. So wait. The bandwidth range, serial interface use 1544 kbps and Ethernet use 10 kbps. It's a many bits second. You can send one at a time. Default bandwidth values are likewise. Default bandwidth values are likewise. These are the bandwidth values and delay. I'll show you in lab also. Delay. We can, if we want to change with the help of interface, we can change the bandwidth. If it is 100 Mbps, we can decrease or increase the bandwidth also. That is depending on our connectivity. And Ethernet link having the 10 Mbps and fast Ethernet having the 100 Mbps bandwidth, and gig 10 gig having the 1 gig. Sorry, this is a 1 gig. 1 gig having the 1 Gbps, 1000 Mbps. This we can change also, but by default bandwidth is this much. And delay, generally delay is calculated in microsecond. The more bandwidth, the less the delay. If the bandwidth is more, then delay also less by default. Yes, if bandwidth is 100 Mbps, then packet will be reach faster than fast Ethernet, right? If bandwidth is more, then the packet will be reach. If you are downloading the movie, then if you are getting the bandwidth 1 Gbps, within a fraction of seconds, you can download the entire movie. If that is 100 Mbps movie, you can within a fraction of seconds. If that you are downloading with the speed of 10 Mbps, that movie, it will be take minimum 10 seconds. So if the bandwidth is more, the timer also less, delay also less, likewise. So the by default delay is, it is 200 microsecond and 100 microsecond and 10 microsecond. Mostly will play with K1 and K3. Here bandwidth and delay. This won't change. This will be the by default values. It won't change in interfaces. If you are using, even though not EIGRP, if you are using the different protocols also, the link cost, the link bandwidth and delay, it is same. Now coming to the load, Load is nothing but the amount of the traffic moving on the link, whichever the we are sending and receiving the packets, that is depending on, we discussed that packet is heavy, means the packet is sending sometime fast, and we are originating some traffic like movie traffic, it is more. And if you are giving the text traffic, is it's less compared to video traffic, the text mail traffic is less. Likewise, the load is depending on that. Once you are seeing the video in YouTube and you are sending the traffic through mail, compared to movie traffic, the text mail traffic is less. That is depending on load. So it will be change. MTU size also say same thing only. It will be change. And reliability, it is calculated based on the amount of the packet drop of or forwarding the packet. If not packet are dropping it, it means the means it is reliable. Means some traffic you are sending or receiving, like just now we discussed R1 R2 entire traffic sending, that rate it will R2 is giving the reply also. Sometimes the traffic will be drop, then here reliability is occurred. He is not giving the acknowledgement, so it will be not constant. Heavy traffic means some packet will be dropped. Sometimes you can assume like you went to Miseva, they will told like the server is down because the traffic is originating more on that time. So that is the reason packet will be dropped. So reliability is not constant there. So you can assume likewise. These three things is will not use. That is the reason these bits are off. Now you clearly understood, I think. These all are the metric calculation purpose we'll use. Based on bandwidth and delay, we'll calculate the metric. If we have the like R1 and R2, first path and second path, and it's a third path. We have a three path. They connected likewise. Here, this is one is a F fast Ethernet link. This one is a fast Ethernet link F, fast Ethernet FE, fast Ethernet. And this one is a gig link. This one is a gig link, and this one is a gig link. And this one is the again Ethernet link. Ethernet link. And Ethernet having the 10 Mbps speed, 10 Mbps, 10 MB. And here we have the 10 MB. And here 1 gig. So 1000 MB, 1000 MB, and here we have it 100 MB. So based on the bandwidth, it will be calculate the best path. Which one is the best path? You are using here RIP protocol. Which one is the best path from source to destination? This is a source and this is a destination. I hope you got my question.
Second path.
I'm using here RIP. As I mentioned here, RIP protocol. I'm using here RIP protocol.
I think first one.
Last one. Number of hops
I missed
less.
that down.
Great. Any other answers? Venkat, how RIP will
Yes, sir.
calculate the best path?
Yeah, it's like a number of ports is less, so that's why we choose the third one is the best.
Why you are not answering? If you guys are not giving answer, then I understood like you don't know the answer. Whatever it is, right or wrong, give the response.
Okay.
Uha,
Yes, the third path is the best path.
okay. Sahiti,
It's a third path.
okay. Now here the prefix is 30 and the prefix is here 24 and here the prefix is 24. Now tell me which one is the best path? Anyone?
Can you show once again?
Here
paths
the
for
prefix is 192, 168, 10.0./24 and same prefix 10.0./30 and here same prefix we are using 10.0. Then tell me which prefix is which path is the best? Now tell me.
I think last one only. Why? Because it supports variable length subnets.
First, how it will be elect the best path? Starting only I mentioned here, client class only, I shown something here. How it will be elect the best path.
I think the path with have fewest sum.
By the hop count.
Longest prefix. In this, which one is the longest prefix? First, it will be C, the longest prefix, then it will be moved to the AD value, then it will be moved to the metric. Router will elect the best path based on this criteria, then ECMP. Equal cost multipath from R1 to some R2. In between some other routers are there. So the prefix 192.168.10./24, 192.168, 10.0/0/30 and same prefix. So here don't see the prefixes are matching. Here I mentioned like it is the longest prefix. First it will be elect the longest prefix. The traffic will be it will be in routing table. It will be stored in this path. Once this path is not there, both are a different path or both are same path. If here also same path /24, then it will be moved to the AD value. If you are using RIP here also RIP. Here I am using EIGR. Now tell me which one is EIGRP metric is EIGRP metric.
AS number?
AD administrative distance value.
90.
And RIP AD value?
120.
120.
And which one is the less?
EIGRP.
EIGRP.
Then it will be moved to the EIGRP. Understood. If EIGRP also, here also EIGRP 90. Tie here. Here also 90. EIGRP, EIGRP, EIGRP. Then it will be moved to the whichever the having the less bandwidth and delay. Here, which one is the bandwidth and delay is less? Sorry, bandwidth is more and delay is less. It will be moved to the this path. I hope now you got it. It will be moved to the metric. The router will elect the best path based on the longest prefix, based on the AD value, based on the metric. Sometimes I'll show you in lab. That is the thing. You will get those things. But now you got it. The answer. Now you got what I'm trying to explain here. Yes or no? This is the important thing. When you are troubleshooting, then you will might be confused so many times. We are using here EIGRP and OSPF protocols. So, and it will be based on the AD values, it will be elect. If you are using EIGRP and RIP, EIGRP AD, OSPF AD value is
110.
then which one is the less AD value? Here, EIGRP again. So it won't see the AD value that time. It whichever less, the routing protocol will be elected. We can use in real time multiple protocols also will redistribute those things prefixes. So that is the reason I'm explaining here. So in real time, whenever you are working location, you will see like multiple router in one router, different routing protocols will use. Understood? But that prefixes will be redistributed to that into one routing protocol to one routing protocol. It will be redistributed. So don't confuse it. We'll use not only EIGRP, not only RIP, not only OSPF. Entire routing protocols will use also in some organizations. See, where we'll use basically. We have a one branch here, R1. And we have another branch here, branch 1 and branch 2. Our entire network is properly working. This is a like XYZ and XYZ company. XYZ company is there. The entire thing is working properly. The business also working properly. One more, our neighbor company is there. Same, their business are same. Say, so they sold their company. So this company entire routing, switching and entire thing will be by this XYZ company. They sold. So here they are using EIGRP protocol. They are using OSPF. So OSPF. So entire thing is working fine. So they plan to, they don't want to change the entire thing, entire routing protocol. If you are changing here Cisco devices, they are using Cisco devices. Though, so that is the reason they are using EIGRP protocol. And here we are using HP devices. So that is the reason they are using OSPF protocol. So these guys are sold this company. These XYZ guys are taken this company. So that time they will use here OSPF also. In this OSPF, they'll redistribute this protocol to this protocol likewise. This is a great example. I hope you got it now. I have given the example like. So that is the reason based on this criteria, the router will be elect the best path. This all about EIGRP. If you have any questions, ask me. We'll move to the lab. And in EIGRP, we have a successor and feasible successor. What does it mean? We have a first path and second path. As I mentioned, if you are using, this is the first path. Sorry, this one is the first path. If you are using entire thing in EIGRP protocol, we have a 3 path. 1, 3, 2, 1. 1, 2, 3. 3 path we have. In this, first it will be elect the bandwidth 1000 Mbps, 1000 Mbps, 1000 Mbps. So first preference is this path, and second preference is this path. This is a successor and this is a feasible successor. If we have multiple path, then it will be likewise will say feasible conditions like EIGRP also per calculate the second best route if it satisfies if feasible conditions. In that we have first one is successor and second one is feasible successor. This is a best route to destination stored in routing table. Backup path stored in topology table. As I mentioned here, we have a first one is neighbor table, and second one is topology table, and third one is routing table. We have a 3 tables. First one is neighbor, then topology table and routing table. I'll show you in the lab those things. We have a first path and second path. Both path it will be stored in topology table. Shall we move to the lab now?